Let me dive right into it without wasting any time, right? So first off, we said we're going to talk about data. What do we think data is? I can give you a million cliche things about data. Data is oil, data is a new currency, data is the amount of data that's being created every day. It's about 8 billion and so on and so forth. At the end of the day, it's as simple as this. When did computers get into existence? When did the internet get into existence? Not too long ago, maybe 20, 30 years. But the amount of data that has been generated was not that much. So there wasn't really a need for people to be able to analyze or do anything with this data. But today, the amount of data that's being generated, and be it in different forms and so on and so forth, the need for data analysts, data scientists, database administrators, database developers, it's enormous. It's never going to get less. It's only going to increase and increase and increase. So that puts you in a very vital situation to be able to go ahead and study this, okay? So data that's being generated really increases exponentially. Now, what is data and information? Fred gave us a very good definition. He said, data is like information that's put together, but data on its own, right? For instance, data on its own could be 25. 25 can be data, but it is not yet information because it doesn't have a context. When you give it a context, for instance, say 25 years, now you understand you're talking about somebody's age. When you say 25 francs, then you're talking about somebody's money in CFA, or you say $25, you're talking about somebody's money in dollars. So you have to give it a context. Then it goes from data to information. And then when you work with it, you start developing knowledge out of it. And then from there, you get wisdom. So there's a whole stage that it goes through. So for instance, Washington by itself, Washington is just data. Until you decide to tell me if it's Washington State, then it becomes information. Or if it's Washington Street, then I know it's talking about a street. Or if it's Washington, the president, right? So all of that tells you the kind of data we're working with. But now data can come in many different types, okay? So one type of data that we are very commonly working with is structured data, okay? Unfortunately, I'll have to tell you that structured data makes up about 80% of the amount of data that's out there, okay? Structured data is what we are going to be doing a lot of here in this course, because we're going to be working with structured query language. Structured data could be things that you see in tables, things that you see in many organizations. All organizations that have been going for the past decades and so on have been depending highly on structured data. But then there's an advent of unstructured data. Unstructured data has to do with Internet of Things, to put it in another word. Unstructured data has to do with pictures, audio, video. That's a lot of what young people are doing nowadays. Nobody has time to be sending you text about this and that. They'll send you a picture, they'll send you an audio, they'll send you a video. How do we get data out of this unstructured format? That is what is really booming nowadays. So unstructured data makes about 80% of the data that's out there. So that's where you have things like Cosmos DB, Hadoop, and so on being useful. But before you can start querying those, you definitely need a good mastery of structured data and how you can query it. So you'll be in a better place to jump into unstructured data when you have a good understanding of structured data. In between the two, you have semi-structured data. Semi-structured data, I'll use words that you probably haven't seen before, like JSON and XML, CSV. Most of you might have heard of CSV. Has anyone in here heard of CSV? Yes, no?
Yes.
Yes, can you tell me what CSV is in your own words?
I don't really know what CSV is, but it's more of like an Excel file.
Very good, very good, very good idea. So CSV, actually stands for comma separated values. Okay, so let me cheat here and type this out for you to see, except I'm putting the wrong one. Let's pull the right one. That's the one I need to put in there. So CSV stands for comma separated values. So think about the structured data I talked to you about. The structured data is in the form of tables and so on and so forth. Now, when you have semi-structured data, it's in the form of maybe JSON and also XML, CSS. It's like metadata, a description of what data is, right? So someone might send you a video. You can create semi-structured data out of that video because you say this video has to do with dancing, or this video has to do with a cat, or this video has to do with soccer. So that's how you'll be able to use it. And then you give it certain properties. Maybe give it a length and say this video is 10 hours or 2 hours. All of those give it some kind of semi-structure out of that data. And you can query it and say, okay, I want to pull YouTube videos that are of length 5 minutes or of length so on and so forth. That's because you have been able to create some semi-structure out of it. Okay, so JSON, CSV, XML, we'll talk about those as well at the end of our course, because these are things that you need to be able to understand, and those are the words that you can be able to leverage and use when you find yourself in an interview situation. Okay, so what other questions do we have? Does everybody feel comfortable about the understanding of what data is, how data can be transformed to information, knowledge, and wisdom, and the different types of data? Everybody feels 5 on 5 on that?
Can you go over semi-structured data again?
Please? Okay, very good. So structured data, everybody knows structured data has to do with tables like Excel tables, right? Relational databases, that's what we'll be talking about for the most part in this course. Then you have unstructured data, which is the bulk of the data we have out there, especially because of the advent of Internet of Things, you know, the advent of social media and so on. So for instance, when you go to Instagram or Snapchat or any of those social media websites, people don't necessarily post only text posts and text messages. They might upload a picture, right? In order for us to get some kind of traction of that picture that was posted, the picture then has some properties that will be allocated to it, or the video has some properties that will be allocated to it, or the audio has those properties that are allocated to it. The allocation of those properties is what makes it semi-structured. So it becomes metadata, description of data, more or less. So for instance, I might decide to say this picture was uploaded on Saturday. It was uploaded in Bamenda. You know, all those things now will give you some kind of characteristics that you're giving for that unstructured data. Or this video has this length, or this video is about dancing, or this video is uploaded from this person. So all those things could be used and put together in a JSON format, which we haven't talked about. Don't worry about it right now. A CSV format, which we haven't talked about. Don't worry about it as well, because we'll talk about it sometime later when we get to the second part of this course. Does that answer your question?
Yes, thank you.
You are very welcome. And I encourage anyone, please, if I'm going too fast, stop me. And if you have any questions, raise your hand or ask me or put it in the chat, and I'll definitely jump on it. Okay? So like we said again, we've talked about data. That was the first thing that we needed to achieve today, the first goal. Next up is databases. Okay? So what are databases? Fred gave us a definition of data, which was more or less in relation to databases. So a database, again, I'd like us to talk about a few things before we talk about databases. I'd like us to think about a server. Does anybody know what a server is? On that. What is a server? A server, most people think of a server as just somewhere where you store stuff, but it's a little bit more than that, right? Server, definitely you store a lot of things in server, and there are different types of server. You could have a file server, you could have a firewall server, you could have a web server, you could have different types of server, a database server as well. A server is used to not only store, but also process. It also processes information or data, okay? So understand what a server is in relation to database. Databases usually reside on a server. So think of a server like a warehouse. In that warehouse, you have different, should I say, cabinets or different sections. Each cabinet would be a database. In that cabinet, you have different drawers, and the drawers will be the tables in there as well. Okay. So again, a database, a bunch of data together, but then you have to understand databases usually reside in a server. You know, different companies again have different servers. Microsoft has SQL Server, or Java. Oracle has its own server. IBM has a DB2, and so on and so forth. Because of that, each of them also have different types of SQL languages that are used to be able to query each of the data in there. So think of the cupboard or the cabinets that you have in that warehouse. You know, if your warehouse is a story building, you probably need a different type of worker. If your warehouse is a basement, you need a different type of worker, and so on and so forth. So if your databases are related, or they have tables that are related to one another, they are usually termed relational databases. So a relational database is usually when you have those tables that are related to one another. And we'll talk about how they are related in a little bit. Okay. So in order for you to be able to work with those databases, you need what is known as a relational database management system. So that relational is from the relation of the tables, database obviously storing data, and then managing the system that is being stored in there. So think of your Excel spreadsheet. Your Excel spreadsheet has multiple sheets. Those sheets are not linked to one another. A database becomes a step higher than that because the database has all these tables, but the tables have keys that link them together. For instance, you might have different cities, and the different cities are linked by the airport, or they are linked by roads, or they are linked by maybe waterways, a ship, and so on and so forth. Now, the key things to define again, like I said, the server, RDBMS, and also SSMS. So again, going back to that, our story of that warehouse is the server. And then you have cabinets in the warehouse. You need a worker to be able to go in there and, you know, pull whatever item that you need, maybe a book, or maybe some drinks, or maybe some grocery items. Depending on the kind of cabinet, you're going to need a particular type of, say, tool. Maybe you need a ladder, maybe you need, you know, a forklift, and so on and so forth. So the tool that is being used to access and query that data is what is known as a database tool. An example of one of them is the SQL Server Management Studio. So SQL Server Management Studio is created by Microsoft. So it's definitely not going to work with an Apple computer. Okay, so that's one reason why I personally did not want us to use SQL Server Management Studio, but there are other tools out there that work regardless of what platform you're using. Another tool would be Azure Data Studio, very similar to Visual Studio for those that write code, but it's also a Microsoft product, but this works with Apple computers, not only with Windows computers. You can also connect with databases on premises, the databases that are stored locally on your server, or databases on the cloud, be it Azure or AWS, and so on. Other tools out there, we'll talk a lot about them in the second half of our program, but those are the two that I wanted to point out to you. There's DBeaver and there's PHP MyAdmin. Now, that said, let's talk a little bit about, oops, that's not what I want to do. Let's talk a little bit about the different types of databases. we talked about different types of data. There's also different type of databases. So databases that are related to one another, that have tables that are related to one another, are known as the relational databases. We also have non-relational databases. So I want you to be very careful here. When you see NoSQL, that doesn't necessarily mean you're not going to use SQL. It does mean that you're going to use SQL and a lot of other tools or services. So NoSQL means not only SQL and not SQL. So relational databases or non-relational databases, you have different tools that are being used. You have document databases. For instance, we talk about CSV files. If you're going to store CSV files in a database or JSON files, those will be document databases. We also have key value databases. Think of it like a dictionary, right? In a dictionary, you have words and definitions of those words. So you store things and you store their descriptions in a key and a value. So if you need a description, you can pull that out. You also have graph databases. This is usually for virtual or for virtual things, when you have to create a node and relationships. The ones that are not very popular are hierarchical, network, and object-oriented databases that we don't really need to talk about. But on here, you can see some of the popular databases out there. Oops, I should not be going forward. I should be maximizing it. Some of the popular databases out there, you can see Oracle is the most popular at about 12 million. And MySQL is popular. MySQL is an open source database, okay? So it's not tied to any corporation. Microsoft does have its SQL Server, there's PostgreSQL, MongoDB, IBM has DB2, and so on and so forth, okay? So this, again, you necessarily don't need to know all of these databases, but you have to understand that SQL query is what you use to query all of these databases. If it's a relational database, you're definitely going to use SQL to query it. Does that make sense? Okay, what questions do we have? Everybody is good so far? All right, I'll take that as a yes. So let's carry on then. What is SQL then? SQL is just a programming language, okay? So that same guy that we talked about, that goes into the warehouse to be able to pull things out from one database to the other, one table to the other, bring it back to you. We need to figure out how we communicate with him. He definitely does not speak our language, so SQL is the language that he speaks. Again, there are many different programming languages out there. We're not going to talk much about it, but SQL is a programming language. It's not a procedural programming language, meaning it doesn't spell out the things that the computer has to do. It just declares what it wants the computer to give it. So you go in there and tell the guy, give me bread. The guy goes and gives you bread. You don't necessarily tell him, make a left, make a right, go up, go down, and then the shelf for bread is here. Okay, so that's pretty much it. But then when databases came into existence, there was just one SQL language that was being used. So that was ANSI, American National Standard of Information, and so on and so forth. We don't need to know that. But that's a standard that was used for all databases. Now, when companies started developing their own databases, IBM, Microsoft, and so on, they started adding more features and wanted new things to be able to be done by this worker, this SQL. So they started creating dialects of that language. That's why we have T-SQL. T-SQL is a dialect, a faction of ANSI SQL. There's also PL SQL, which is programming language SQL. So it's always good to know that. But let's continue. Now, when we talk about data, there's a few things that we need to understand, okay? So data could be in many forms. I did say in the beginning that, 25 is data. 25 is a particular type of data. We'll call that a numeric type of data, okay? Also, Washington is another example I use. Washington is a type of data. Washington would be a string, or in this case, a VARCHAR. So there are different types of data. Think about going to a bank and requesting that you want to open an account. right? So it depends on what you're going to save in that bank. If you're going to the vault to save your important documents, birth certificate, and so on and so forth, then they'll know that, okay, we're going to give you a drawer, right? That's the amount of space that they'll allocate for you. If you go in there and you probably just got out of the forest and you've dug up 3 gallons of gold, and you tell them you have this much bullion of gold, they're going to give you a storage room, right? So it's the same thing with our database. When you create an object, you need to tell the database what you're going to be saving in there. If you're going to be saving just numbers, then it will understand that, okay, I need to reserve you this amount of space. So that's the main reason why we have different data types, so that we can better manage our resources. So data types, you have bits. Bits is just short form for binary digit, okay? Either a 1 or a 0. That's usually the smallest form. But a bit can also be true or false, yes or no, because they're going to use 1 and 0 to represent those Boolean values. That's what it's known as. An integer could be of 4 different types, depending on the range, depending on the size. The smallest size would be tiny int. So it has this particular range. I'm not going to bother you guys about that for right now. There's also small int, which has a wider range, and int has a bigger range, and big int has even the biggest one. Okay, so those are whole numbers that range from tiny int is just positive, small int is usually from -25 to the power how many, and so on and so forth. So decimal again is also another type. Numeric money is more specific because you save it to 2 decimal places if it's US dollars and so on. There's also float that has double precision of a decimal, and then you have real numbers. For characters, it's important to note that a character has a fixed size. For instance, if you're going to save just the abbreviation of a state, then you know it's always going to be 2 characters. In that case, you're going to use the character data type. But if you're going to save somebody's first name, we all don't have the same length of our first name, then you want to use a variable character, which is VARCHAR. Some people call it VARCHAR and so on. When you use that, you have to specify the maximum length that you need for your string. So if you're going to be saving up to 225 characters, that's fine. I think that's something that we had before with WhatsApp. WhatsApp probably created a field that was saving the number of members in WhatsApp to be 255. So apparently, as they got more money, they got more space, they were able to get bigger servers, I think. So they decided to extend that. Now you can have a group with more than 255 members. Also, a few other data types that are important are date. It could be just the date, just the time. You could also have a date time, or you could also have a timestamp. We're going to find these a lot, but now I'm talking to you, we're going to practice it, and you will definitely remember all of them when you see them. Binary is also important. Like I said, bit was binary digit. Binary could be a single binary or a variable binary. You could have images and so on that are saved in binary format. And finally, you have Unicode characters. And these are just variations of a character and a string, because depending on what country or what keyboard you're using, maybe you're using Japanese, Chinese, and so on, you want to be able to accommodate for their characters, then you might use CHAR and VARCHAR. All right. So again, you don't really need to memorize this. Just understand that you have different sets of data types depending on what you're going to save. And when we talk of data and databases and SQL, we're going to talk about transactions. And those transactions will have to be consistent. They'll have to be atomic. They'll have to be taking place in isolation. And they also have to be durable. Okay, that's known as ACID. Let me go ahead and write that down. I think I did not include that in my slides. So each transaction has to have those properties. So when you have those properties, then you know that you're not going to break your database, because acid again, atomic. Let's go ahead and for atomic. So that means a transaction, all of it happens or none of it happens. So it happens totally. And there's also C for consistency. So this means if you have decided that you're going to save just numbers in a location, you cannot decide that instead of saving just numbers, you're going to start saving letters or binary. It's going to cause consistency issues, and we're going to have referential integrity issues and so on. So we want to make sure that our data is consistent. But normally, SQL will tell you that there's an error because there's no consistency and it wouldn't affect that change. There's also I, which is isolation, if I can spell correctly. So every transaction happens in isolation. For instance, if you're removing $10 from my account and crediting someone else's account, you cannot only remove my $10 and not credit the other account. So they each happen in isolation of one another. And finally, there is durability. That's an easy one. So it means once you make a change, it's going to stay the same, as change is always going to be in effect, whether the light goes off or someone cuts the light or whatever happens. You know, it's going to be durable. You come back tomorrow, you'll see that change that you did yesterday. Okay. So those are a few things that I forgot to point out, but it's always important to note them. All right. Now let's jump on to the next item, database objects. So databases, again, as I said, have different objects. Think about your cupboard or the cabinet again. The very first object I want us to talk about is a principal. A principal is more or less you, the person that's going to be using the database. Not necessarily you going in there, but the login that you're going to use to get access. So the principal is actually what requests access to the database and the resources that the database is going to use. It doesn't necessarily mean it's going to be just a single user. In some cases, maybe you work on the IT team, or you work on the database admin team, or you work on the security team. They might add you to their team principal. So a principal can be a single user, or it can be a group of users, depending on how the system is set up. So that principal is what's going to request for maybe access to a database, make changes, and so on and so forth. So when all of those are taking place, you'll refer to that as a principal. We'll see some of those as well. Actually, let me jump in real quick and share that with you. So right here, if you see, I'm actually using Azure Data Studio. I'm logged in as, I don't have a query running, but if I go ahead and start a new query, you should be able to see at the bottom who started a query. It should tell you who the principal is, what server I'm connected to, and so on and so forth. So we'll get to look at that when it's time for you guys to log in and play with the database. Okay, so just wanted to point that out. Now, principal again is the person requesting those resources. The next one we need to talk about is a schema. Does anybody know what a schema is? Anyone like to share? Especially if you're not sure and you need clarification.
I think a schema is data structure.
Very good. A schema is data structure. So as it says here on my cheat sheet, it is data structure. It is database structure. It is a container. So think about it this way. You know, a database is that warehouse. You know, you have all these different cabinets in there. Maybe you want to separate it. I don't want you messing around in my place, because tomorrow when I come back, I don't want to look for something and it's not there. So it's that same idea. When you drop off kids in a nursery school, every kid has their sandbox. When I put my toys in here, please don't come and mess around with my stuff. So that's pretty much the same scenario here. Remember, your database resides in a server. When your database is in that server, the sales department will have their own schema. They don't want people messing around with their stuff. The HR department might have their own schema, because not everybody in the company needs to be seeing everybody's salary. Only them have to be able to see some tables that have critical information, like people's personal information and so on and so forth. So a schema is a container. You as a principal, you can also decide to create your own schema. I want to have my tables that nobody's going to be messing around with them, except I decide to give them access to it. So you can create your schema and play around with it as you need. So we're going to create a schema today so that everybody can go ahead and play with their stuff, okay? So the schema in this case is a container. So when you're asked to give a schema diagram, it's just representation of the tables within that schema. So the schema for fees might be different from the schema for sales, might be different from the schema for IT. Some might have the same tables, some might have different tables. Does that make sense? All good? Awesome. Now tables, everybody's familiar with those. Tables, they're made up of rows and columns, right? Just like in Excel. Each row represents a record, represents an instance, but the columns are just fields, they are attributes, they are characteristics. For instance, if you have a table that is called cars, you might have a few attributes that you want to be able to capture for your car. Maybe the year of the car, maybe the make, the model, the color, and so on and so forth. But then, if I have to decide that my car has these particular attributes, my car is going to be on a single row. Your car is going to be on a single row. If you have 10 cars, then they're going to be on 10 different rows. Each one of them has a year, each one of them has a make, each one of them has a model, and so on. So that's how structured data is being represented in a table within a database. And it's very important that we talk about normalization, because normally if you have a pen and a paper and you're recording all this stuff, you have repetition a lot. You have things that are not being consistent. You know, you'll be adding stuff and removing stuff. It'll make a mess and it'll make it very difficult when you want to query or when you want to find questions to your data. To make life easier for us, there is normalization. This is not something that we need to worry about. The guys that are the architects, the guys that are creating the database, are creating all these objects in the database, they are the ones that have to make sure that it's very normalized. So at the end of this course, we're going to create a few objects. We'll make sure that we'll look into that normalization. So normalization just makes sure that our data stays intact. There's data integrity. We don't have duplicates all over the place. And then the data stays consistent. With all of those, it makes life a lot easier when it's time for us to query it. If your architects on your team or your company did not do a good job in normalizing the database, you're going to have a hard time running queries. The queries are not going to be performant, or they're going to give you misleading data, misleading results, I should say. Okay. So finally, relationships, again, they're being created based on the keys. Those are the primary keys and foreign keys. I'm not going to talk about constraints today because we'll talk about them later. But these keys are what help us to link one table to another and create joins based on those, okay? So that's it for database objects. What questions do we have?
I have a question about data types.
Yes, go for it.
So what's the difference between decimal and float? I think they are, I mean, I understand them as the same thing, but
Very, very good question. What's the difference between decimal and float? In other programming languages, you're not going to see float. Float is actually known as a double, okay? Like in Java, Python, C#, okay? A decimal and float, the difference is similar to the difference we have with tiny int, small int, and so on, okay? So decimal, again, why is this not giving me what I need? Okay, there you go. So decimal, nope, it's not, never mind. Decimal and float, the main difference is the precision, right? Decimal can only go to a certain number of decimal places, while float, which has double that precision. So if you want to be very, very good with your performance, you probably want to set up your columns to be decimal, to have the minimum amount. When it gets to the point that you have exhausted it, then you can set it to be a float. So for instance, if I'm working in a company where I know we don't have too much data to carry, there's no need for me to set up all my, structures to have big int. If I set up big int, I'll be taking up a lot of space. So think again about that trip that we made to the bank. And we said we want to save maybe this time we want to save just our jewelry, just our important bling bling. And then they go and give us a big room that we should be saving our jewelry in there. That'll be a waste of their resources. If I'm going to save jewelry, then they'll take me to the vault and give me one tiny drawer and put your jewelry in there. That's fine. That's a more performant and a more efficient way of utilizing it. So the difference again between a float and a decimal is just their precision, the amount of space that they take in memory. Does that make sense? Yeah, so in some cases, if you see everybody creating stuff and putting float, they're wasting your resources. So think again about you going to download an app from the store. If you go and open up your phone and you try to download, say, a new application, a few things you look at is what's the size of the application. If the application is 1 gigabyte, I don't need to be downloading an app that has 1 gigabyte. No. If the two of them are doing the same thing, I'll download the one that's 1 megabyte because it's not going to take up all the space on my phone, right? So you want your application, you want your database to be efficient and also not take up all your resources. Does that make sense?
Yeah, thank you.
You are very welcome. What other questions do we have?